Hi future doctors, welcome to the next class. We were discussing induced EMF. So according to Lenz's law, we gave E is equal to minus d phi by dt. So phi can be written as dA cos theta. We have given some equations. A negative sign is going to give, which is going to oppose. Which is going to oppose means, so which is causing it. So if you are bringing magnet towards the coil, so the current developed within this coil in such a way that this current is going to oppose which is causing this current, which is who is causing this current means this magnetic field. So after getting this current, this is going to be opposed by this. This is only, we will say, significance of Lenz's law, law of conservation of energy. Significance of Lenz's law, law of conservation of energy. Otherwise it will not valid if it is not opposing. So without reading you are going to get marks, without copying you are going to get marks. Without work you will get money. That is impossible. So that is nothing but law of conservation of energy is going to be valid. That is the significance of Lenz's law we are going to see. Now how they will give problems on this means, magnetic field in a ring of radius r which is placed perpendicular to the magnetic field. Ring is placed perpendicular means its direction is parallel to the magnetic field. So magnetic field is varying, like B is equal to some B naught or A plus BT. So our wish, that is A plus BT. A, B are constants they will get. Then what is the induced EMF they will ask. So E is equal to our formula. So minus d by dt of BA cos theta. So here direction of area and B both are parallel, therefore theta is 0. Minus d by dt of BA cos 0. Next, area is constant, area is not changing. Area of the coil is minus pi r square, I am writing outside, d by dt of, what is B they give? B is nothing but A plus dt. So now what is derivative of A? Minus pi r square. So these are the only basics. These basics we have given in our basic videos. Derivative of constant is 0. Derivative of bt is B. Therefore minus pi b r square. So this B they can give in their own wish. Here we have given like this, AT plus BT square they can give. AT plus BT square plus C they can give. That is their wish. At that time they may give here time value also or equation also they will give. So B is equal to B naught into e power minus alpha t they may give. So that is their wish. At that time derivative of e power t, log x they will give, log t they will give. That is their wish. You have to know this differentiation very clearly. dB by dt. Sometimes same ring, area is going to increase or area is going to decrease, radius is increasing. So at that time, how to do? Now B is going to be constant, magnetic field is going to be constant. Now area is changing. Area is changing means radius, it may increase or decrease. Then what is the induced EMF means? Now area is changing, therefore remaining terms you can write outside. B cos 0 d by dt of area of the ring is going to be pi r square. Therefore minus B. So derivative of pi r square. Again pi is also constant. Dr square by dt. How they will write means 2r dr by dt. Derivative of r with respect to t. So derivative of x with respect to y, like that we did in basics, minus 2 pi br dr by dt. This is the induced EMF in this case. So sometimes they will give this area n cap is going to be rotated. Already I said in previous class. Then what is the flux? So E is equal to minus BA. Now theta is changed. Minus BA cos theta 1 minus cos theta 2 divided by. So this time they are going to give, just I am giving formula here, minus BA. Initial angle is 0, cos 0 minus cos 180 divided by time. So minus BA cos 0 value 1, cos 180 minus 1 divided by time. So 1 plus 1 minus 2BA by dt. If they ask a magnitude, it is going to become positive. So for 1 ton, we are writing all these things. If it is having n number of tons, E is equal to minus n d phi by dt, they are going to write. So on this only, E is equal to minus d phi by dt. So this is a coil. This coil will have resistance capital R. Then what is the current produced in this coil whenever magnetic flux is going to be changing within this coil? So current I is equal to, we came to according to Ohm's law, V by R. So here it is going to be E by R. So if they are asking magnitude of current, they will ask, then E is d phi by dt into 1 by R. Isn't it? Very simple question. So in previous question, how they gave flux 2t plus 3t square. So what is the current at t is equal to 1 second if resistance of this coil is 10 ohms or 5 ohms? They are going to ask like this. At that time, first we have to find EMF. How you will find EMF? E is equal to minus d phi by dt. Minus d by dt of phi value 2t plus 3t square. So minus d by dt of derivative of 2t. Directly we can do. Already we wrote na derivative. Derivative of 2t, 2 plus 6t. So in place of t, how much we have to take? 1 second. If you are taking 1 second, so minus 2 plus, that is going to be minus 8 volts. If they are asking magnitude here, 8 by resistance is going to be d5 by dt value we got 8, that is EMF. 8 by 10, 0.8 amperes. So like this they are going to ask. So in previous year questions, they asked on this equation. Very simple. Once you came to know E, current we got. Not only current, we can get charge also. So from this I we can write dq by dt. dq by dt is 1 by r d phi by dt. Now if we cancel this dt, this. So dq is equal to d phi by r. So charge is going to be equal to change in flux. Change in flux by resistance. This one also we can get. This is also important formula. So if you know change in flux, you can calculate charge by knowing the resistance of that coil. This change in flux they are going to give phi is equal to BA cos theta in terms. So we were discussing continuously on this equation E is equal to d phi by dt, isn't it? So this is about according to Faraday's law how they ask questions on current, charge, and magnitude of induced EMF and how the flux is going to be changing within this coil. So now you can practice problems on only these equations. So 10 to 15 minutes or half an hour, definitely you can become perfect.